What's up, freaks? This was brought to you by River. River's a Bitcoin company built by Bitcoiners for Bitcoiners the right way. There's no trusted third parties. They build all their infrastructure. They have free DCA because they know it's the best way to buy Bitcoin. So if you want to buy Bitcoin, you want to mine Bitcoin, you want to send Bitcoin over the Lightning Network, you want to plug into their Lightning Network API. If you're a developer, they're building all these tools for you. They also encourage self-custody. Again, they're Bitcoiners. They want to provide an on-ramp for you and then teach you and encourage you to take control of your own Bitcoin. And they're doing this. It's a beautiful company. If you do hold Bitcoin on the exchange, you can know for sure, since they don't rely on any third parties, they don't lend your Bitcoin out, they don't speculate with your Bitcoin. Your Bitcoin is held in a multi-sig wallet with 100% reserves. Okay? So go to river.com/TFTC, take advantage of the no-fee DCA. You set up your dollar cost average. You don't pay any fees on those buys. If you're a developer, they have their Lightning Network Services API that you can build on. You can send over Lightning. You can mine via River as well. You may have your exchange. You may be comfortable with it, but have you tried River yet? It's a question you have to ask yourself. If the answer is no, go try it. That's where all the Bitcoiners are hanging out. That's where I get my Bitcoin as well. River.com/TFTC. Thank you guys for listening. If you're listening on YouTube, please subscribe, set the notifications up as well. We're going to be putting out a lot of content this year. If you want to subscribe to the podcast feed as well, if you're not around your computer or not listening on YouTube, but you want to catch the podcast on the podcasting feeds, subscribe on your favorite podcasting app. And if you want to learn more about Bitcoin, I write a newsletter almost daily during the week. Go to tftc.io, subscribe on the website, and you'll get pure signal on Bitcoin, macroeconomics, geopolitics, whatever tickles my fancy that day. Thank you guys for joining us. Thank you for supporting the show. If you can subscribe, rate, review, goes a long way. We're trying to blow this up in 2023. Enjoy the rip.
You've had a dynamic where money's become freer than free.
If you talk about a Fed just gone nuts, all the central banks going nuts.
So it's all acting like safe haven.
I believe that in a world where central bankers are tripping over themselves to devalue their currency, Bitcoin wins. In the world of fiat currencies, Bitcoin is the victor.
I mean, that's part of the bull case for Bitcoin.
If you're not paying attention, you probably should be.
Rete and ASIC, we're live.
Sweet.
Is this your first podcast? Second?
It is, yes. Well, I do some podcasts on the side with friends. It's called The Disagreeables, and we sort of disagree well is sort of the play on words there. Yeah. But other than that, yes, nothing formal, nothing Bitcoin specific. So this will be my first Bitcoin podcast.
Rete, I can recall one you did with Tom a few years ago.
Oh, dude, that was a while ago, and I've taken a hiatus ever since. But you know, it's been a while.
It has been, and I'm happy to bring you out of the hiatus and to bring you away from disagreeables to TFTC, ASIC.
Oh, love it.
Freaks, how to preface this? I mean, obviously, if you've been listening to the show a while, you know that I've been involved in mining.
Oh, yeah.
Not you two. I'm talking to the audience right now. They know I've been into mining, but I'm really the ugly face in front of the mining operation and everything I've been involved with in the mining space, whether it be Great American Mining or Cathedra and some side projects. These two gentlemen that I'm speaking with today are the brains behind the operation, actually plugging in the machines, setting up the management systems, really designing a process and farm management and what else? Logistics to make everything work. I think you guys are two of the unvaunted individuals in the space who have done a lot of work that many people don't really know about yet. So I'm excited to get you guys on to highlight what you've done, because you guys have done some incredible stuff. I think We should start with Great American Mining, REIT particularly, like talking about that first pilot container that we had up in Utah.
Oh yeah, the ugly one.
Yeah, you could barely call it a container, but yes, it did mine some Bitcoin, so it had that going for it. So I mean, Rete and I, we met back in 2018. We were working on a hydrogen project together. This was before Great American Mining. It was like a pure R&D phase, and we reached a point in 2018. I mean, this is the depths of the bear market when we were trying to integrate mining tech with this hydrogen tech, and it ended up just not working out. We decided to move in a different direction. So we're demobbing this site, pulling out the miners that we were using. The Dragon Mint T1s is what we had on site. So RIP, anyone who bought Dragon Mint T1s. But yeah, basically we're pulling all these miners out and putting them into storage. And I was just like, gosh, I wish there was something we could do with these things. And so, I was chatting about it with Rete, and he was driving home one day, looked at this giant flare out in Utah. He's like, wait a minute, there's a bunch of energy there. Maybe that we could do something with this. And so this is before Rete and I were formally working together. We were from two different companies working on this R&D project. And so I went to my boss and was like, hey, look, I think we can do this. He's like, all right, look, I put a bunch of money into this. It hasn't worked out. I mean, Dragon Mint T1s. I mean, come on, you can't blame him. And he's like, all right, look, guys, I'll let you do this crazy thing. I've never heard of anything like this. You got 5 weeks, and you still have to demob the site. And so Rete's like, how the heck are we going to get gas in 5 weeks? Like this is just crazy task.
We got it in 3 days.
It's like, Rete, look, you're our guy. If anybody's, yeah. Well, that was all Rete. I had nothing to do with that. And so he's like, he calls up his buddy at a wastewater or a water processing facility, from the produced water that comes up when you're pumping oil. He's like, hey, can you just give us some of this gas that's entrained in your water that's coming in? He's like, it sounds crazy. I guess we'll try it out. And so he was like, all right, sweet. We got a place to do it. Now we just got to go. So like literally in the morning, we'd go to this site, this R&D place. I would be taking out miners, electrical panels, wire, we're taking apart the site, right? I'd be taking stuff out, loading up, carrying it over to, and this is the other bit. Rete had a buddy out there, and he's like, hey, can you just give us a patch on this gravel driveway that you've got, just so we can just build this mining thing? He's like, I guess, sure. And so literally I'd load up in the morning, take the parts over to his friend's driveway, and we would like unload it and start, and we'd be building. We had a hand crank generator for power. There's no internet. So yeah, that was kind of the origin.
That was the
story.
genesis.
Yeah. And every now and then Rete would look at me like, this is crazy. Like why are we even doing this? I'm like, look, it's just like it's like the first Iron Man movie. We're in the cave, we got a box of scraps, and it doesn't need to be pretty, it just needs to get us out of the cave, and then we can build better stuff. Yeah. And we did it in 5 weeks, and it was enough to justify building a second one that we actually had a budget for. We weren't just using spare parts, and that turned into Great American Mining.
Yep.
That is a Great American Mining origin story, freaks. Rete, what were some of the main lessons we learned on that first proof of concept deployment?
Well, if you think mining is sexy, it's not. It's hard. You get bloody knuckles, you get everything else, and you don't know what questions to ask if you haven't done it before. Because all the iterations that we went through on those containers, like the second one was, our air intakes on the first one were like that big. Then the second one, it was the entire wall. Then bigger fans, bigger, just everything got scaled up because we found problems in airflow. And then we realized that the first Christmas tree design was a horrible one because it took 3 hours to change out the filters. Whereas, a different orientation took 10 minutes. So everything was, you can put everything on paper and it's going to look okay. But when it comes down to actual functionality, it's like you have to have user experience. You have to have, the right engineering that goes into it. You have to have, especially if it's going in remote sites, functionality that you can do from your couch. Right. And all that has to layer on top of each other.
Yeah.
And that only comes from experience.
Yeah. And to that point, I was going to say, to that point, doing stuff from your couch, that includes building remote systems that allow you to tap into the site and control fans, control the airflow walls. Like if it's cold. With that Christmas tree design, maybe it was hard to change the filters, but did keep snow out, correct?
Yep. After two or three repairs, yes, it did.
Yes.
Well, oh, sorry. Go ahead.
No, you go ahead.
Yeah. I mean, really, one of the things that I've sort of come to is you can solve these problems with one of two ways. You can do it with people, or you can do it with technology. So, in general, you can think of mining facilities as falling into largely one of two camps. Either you have a campus-style Bitcoin mining center where you've got, everything is in one central location. You have, big beefy power lines bringing in power site, or you've got one sort of hut where people camp out. You can do your repairs out of there, and something goes wrong, you send a guy down to whatever aisle it is, and they go and fix it. Then you have sort of these more remote style builds, and that's what we were doing at Great American Mining. You've got a pad 2 hours away from the nearest airport, and if you got to go out and do maintenance on that, it's tough to get out to. And so we had to have command and control systems where you could adjust the temperature. The very first builds we did, nothing was automated. We hadn't figured that out yet. And, props to Austin on that. He did a really great job taking some of those long nights that we did at first and, automating like, okay, this is how the miners work best. What are you guys doing? When? Let's automate that. So, he did a great job, really helping us, scale up Great American Mining. And it was just, you're not going out to a site easily, so you need to have good information so that what's broken, if something breaks, or what the problems are, because you got to figure that all out remotely. Because if you're driving out there, you got to have the tools you need, the parts you need, whatever it is, before you're going out there. It's really time intensive. So, remote control and good information are key if you're going to have a distributed style build.
Yeah. So what would you guys, obviously Upstream Data was around, Crusoe was around when we were building the first iterations of the Great American Mining boxes, and more players have come to market since then. You have Giga, a bunch of other players that I can't even name off right now, but what would you guys say is the state of the market of off-grid mining, particularly with these containerized systems and the control systems? Is it night and day from where we were in 2019, 2020, or are people still learning on the go here?
Everybody has gotten better. I have to say, even give props to Steve. Usually when I look at a design, I can say, okay, I know what he did and why he chose to do it that way, if it's a good design, right? Everything is a trade-off. There's no such thing as a perfect design. It's saying, what are my hierarchy of needs? And they're clearly defined downwards. these remote boxes are not the cheapest boxes on the market. So, you know, right now, cost for most people is at the highest point in their needs. Like, oh, I can get a box cheap, but that doesn't mean that it's going to function remotely in the way that you want it to, or even in a campus style for that matter. So if cost is at the highest and you need to have more automation or you need to have more data, that's not going to be your cheapest option. So you're going to trade off, as Isaac said, the people component is going to be a bigger portion of your operating costs at that point.
Yeah. And so what do you guys think is the Goldilocks perfect trade-off model for these off-site boxes or off-grid boxes, excuse me? Is there a perfect one?
I mean, you have to have automation like on-off on the each outlet, right? Like that's number one. But, you know, our new design has like PLCs, kind of lots and lots of variability with it. I think you can get away with kind of like microcontrollers and get something a lot more scaled down and still make it work. So, you know, cost is going to be, how can you get the same amount of automation for the lowest cost and really hone in on all the data that you really need? And that's kind of where the step is right now, saying, all right, how do I pare this down to what I need? And what resources can I use? Because a lot of these boxes that especially like Steve, even Digital Shovel, they have heat recirculation for cold areas, right? Like that's something that we've done since the beginning. Is like we need to recirculate some of the heat if it's a super cold area and bring that into the intake so that we're not blasting the miners with like negative 20 degree, negative 40 degree air. So all the manufacturers who kind of listen to their customers have said, okay, here are the problems that we've seen, and then they start adding on some of those functions, and that has been very apparent over the past couple of years.
Yeah, you touch on a very good point there. Like, not all off-grid mining is the same. Obviously, if you're mining in the Bakken up in North Dakota, yes, your needs, your pressing needs are going to be different than if you're off-grid mining in West Texas. And how do you design a system for that?
Yeah, it's really hard to make a one-size-fits-all system, period. Because in Texas, your bare minimum, you're going to need to have like a water curtain and adiabatic cooling. In North Dakota, you don't need that, period. But you need a lot of heat recirculation. You need to have kind of environmental protection measures. The biggest enemy is really dust for a lot of these miners as well. So environmental control, the minute you put in filters, you're going to have pressure drop, you're going to have resistance to airflow. But you're protecting your investment, you're protecting your miners. So is it really worth it? Yeah, in my mind.
Yeah.
Yeah. So I mean, Rete brings up, a spot on point, which is that, every site is unique. In particular, if you're doing flared gas mining, you need to get a gas analysis. Sometimes you need to treat that gas. There's a litany of tiny details that come crawling out of the woodwork. Anytime you say, oh, I just want to mine here. It's like, okay, well, what we would look at things like, what's the prevailing wind direction? What's the we would just Rete's really good on that sort of thing. Once we sort of identify, hey, we want to do this, he just goes, he's like an electron microscope. He goes right down and will find the smallest of things that are he didn't know were important. And it's like, oh wow, I didn't think about that.
You could call him an electron microscope or an ant fucker. Like
there it is. Yeah.
What is
the ant fucker? Yeah.
What is the definition of an ant fucker, Rete, in your mind?
Well, let me put it this way. I don't consider myself an expert, but I definitely know what has caused me pain. And so I would consider it as, all right, that's caused me a lot of grief. How do I fix that? And how do I bring that and make that next iteration better? So that's why I would consider an ant fucker. It's like all the things that have kind of led up to this point of where you want to focus your energy, because it has either caused you a late night or freezing cold temperatures or just time, really.
Yeah, so the ants are the very small details. So I guess
Always.
What you're getting at is the very small details in these off-grid operations are very important.
Yeah.
Yep.
I mean, one thing, for example, is when a gas well or the gas from a well becomes unstable, you don't want to have your gensets running at full tilt, right? So, do we look at the generator and see, is it going to shut down? Or do you look at the gas and the gas supply pressure? And so, like, kind of figuring out where you need to look on the energy supply system, that's where you can get a competitive advantage, because you need the containers or the miners or the load on the containers to pare down, shut off, and go into self-protection mode. Because if they don't, and you don't have eyes on it, we've seen the horror stories of caked on snow into machines because the door wasn't closed. You don't want that.
A very small and actionable detail that everybody should close your fucking doors, people. You don't want the snow or the dust getting in.
Yeah.
But no, I mean, you touch on something else there. Like we've been talking predominantly about like working within the box and the whole mining operation. But you mentioned the whole other side of that, which is the power generation gen sets, which is like a whole other Pandora's box of problems and intricacies to work through.
Yeah. Your primary goal is to keep the gen set up and running. Mining is actually your tertiary thing. So you want to make sure you have gas, your genset stay up, and then your miners are on, right? Because without that cascading sequence, you're not mining.
Right. The big thing is, if you don't think about how these systems integrate with one another, you're going to pay for your lack of knowledge or lack of planning with downtime. I mean, you need to have an understanding of how is this well working, how do the generators work, how does that all tie into the container. It all matters, right? And for instance, if you turn miners on too quickly on an off-grid site, you can basically cause the generator to suck down gas faster than the pipeline can sometimes provide it. And then your whole site gets shut down, and then you're sending technicians out there to get things back up and running again. It becomes a mess pretty quick. And so you can automate some of these things, but really, since each site is sort of unique in terms of the systems you're tying into, you need to do an analysis of, well, how does this system work now, and is our current build a good fit? And going back to your question about, hey, what's the sort of the Goldilocks zone? I think probably. So in general, I think the space is still developing a lot. I don't know that anyone has sort of cracked the code of, hey, this is a one-size-fits-all build. And part of that is there's a litany of little details you have to think about. I think probably what will end up happening, if I was sort of try and pull out my crystal ball and say, hey, I think this will happen, I think you'll probably see some sort of a base model that suits most needs. And it will be built in such a way that you can easily have these bolt-on solutions. So, regardless, you have to have a rack that the miner sits on. Yeah. You have to have wires that bring power to that miner. Yeah. There are certain things that don't change too much. And I can see a world where people, where somebody figures out, hey, this is the base model. This is the bare bones, what we need. In most markets, and here are these simple add-ons. You can quantify exactly how much they'll cost and say, okay, if we're going to go down to West Texas, here's here's a water curtain or a water mister bolt on, with maybe some kind of water collection on the roof or something, right? And then you go up to North Dakota, and all of a sudden heat recirculation becomes more important. So you sort of create these different bolt on technologies. And also, in terms of, remote control of power cycling, I think the industry is going to head toward, okay, here's your, think about like, an ant box where it's just, bare bones, basic electrical. Okay, well, let's get something that would allow us to do automation as a bolt-on technology. So if you don't need automation because you're in a campus style, you always have it staffed, you don't need it. But then if you want to do a remote deployment, here's this bolt-on package. You can just add it to an existing container, and then you're off to the races. I think that's where we'll head. Making all of that work well is a really challenging task because there's so much going on that it's not as simple as you might think once you actually start getting into the details of it. But I think that's where we'll end up heading.
So the market for purchasing containers is going to be similar to the market for buying a car, where you decide what gadgets and upgrades you want.
Right. I think
exactly.
So.
Yeah.
Walk into the dealership, so to speak.
What does it feel like for you two to be on the cutting edge of this budding industry, like tinkering with this stuff? Some of the first two individuals. I mean, I imagine the population of people working on the particular problems that you guys have worked on is relatively small.
Yeah, I mean, in the beginning, it was nuts. I mean, there were no YouTube videos about this stuff. It was just like, okay, here's this sort of electrical video on YouTube that sort of says something about what we need. Looking up articles on HVAC. Thermodynamics. Textbooks from way back when.
Yeah.
I mean, it was pretty crazy because there weren't like good resources. It was just Rete and I, sometimes we felt like, Dumb and Dumber. I'm telling you, because we're just sitting there like, I don't know if this is crazy or if maybe this will work. And we just had to try it to find out. But it was always a case of, look, we just need to make enough right decisions. And, part of that is just staying really humble and, just when you're in the thick of it, when you're in the pain, say, okay, reality is going to tell me what it needs to make this work. And I just need to listen and stay humble and just work hard. Sweat equity will go a long way if you're willing to stay humble. And I think a lot of other miners, a lot of other people in the space, they're in that process, and people are putting in the sweat equity, and they're going to make it. That's what we had to do. It was just work hard, stay humble, and be alert. The information's all over the place if you know where to look.
Yeah, listening to what the data is showing you, so you have to kind of overbuild to gather that data and kind of. I mean, we didn't know. I mean, one of the mistakes that I made was I sized the fans incorrectly because I didn't think about the expansion of air on the hot aisle by 11%, right? So my the fans couldn't keep up. The hotter air expands in volume, and it's like I'm just not quite there yet, and so everything after that was had at least a 20 to 30% margin. So
it's crazy to think of. I mean, you guys mentioned it earlier, a lot of people think like, oh, it's simple, you find a strand of gas well, you find a generator, you plug it in, it works. But this is again a cutting edge engineering problem that a lot of people are trying to solve right now. Like when that was like the most fascinating part about working in Great American Mining, working with you, Austin, Tom, now you guys continuing that at Cathedra. Like I've learned more about like physics, petroleum engineering, electrical engineering.
You're telling me.
In the last 5 years than I ever would have expected. Like if you told me I would have learned this about this particular domain when I was 21, I would have told you you're crazy. But that's what Bitcoin mining, particularly in this off-grid environment, forces you to do.
But it's energy, right? Like it's how do we get to energy? And that's really how I got into the Bitcoin space, is like there's such this beautiful relationship between energy and Bitcoins. I just see a lot of waste that goes on in the energy space that it's as much as I hate saying is like Bitcoin fixes this, right? Like energy has this why waste it when you can use it for something? And it's not a scarcity thing. It's saying, how can we be more efficient in the way that we use it? And there's no better way.
Well, at a fundamental level, just one of my overarching principles in thinking about this stuff is, look at nature. Some of humanity's best inventions comes from mimicking what nature's doing. And what does nature do with energy? And if you look, every waste product of an animal or a plant, any organism on this planet, any waste product is food for something else. That's just how nature works at a fundamental level. And so you say, okay, what is Bitcoin food? Yeah, it just, and it's very rudimentary, but at a fundamental first principle level, Bitcoin requires energy, specifically electrical energy. And it's like, okay, well, I need electrical energy that doesn't, just, pop out naturally in the world. So we need to find other energy forms. But still at that fundamental first principle level, you say, okay, where is there wasted energy? Where is that the waste product? And that's where Bitcoin can. Industrial scale, you can do that with flare mining. At a very small scale, you can use Bitcoin miners to heat your home, right? Because that's something that you need anyway. And in New England, we just burn oil in an oil burner to heat homes. We usually don't have gas hookups. Worst case, you have, there's literally people buying, space heaters, just electrical space heaters. And I just prefer mine to be subsidized by Bitcoin. But the point is, there's wasted energy all over the place. I mean, I just think about clothes dryers, like just tumble dryers. Tumble dryers in the US use more power than the Bitcoin network currently. I mean, what if you just dried all your clothes with Bitcoin miners? Just integrate the chips into a dryer. I mean, anywhere you see just energy being expended for its own sake, Bitcoin can insert itself there. And it sort of gets at what our mantra at Cathedra. Hey, we like to be the cockroaches. We're the cockroach model, because there's all these little nooks and crannies where energy is being wasted, and Bitcoin can thrive there. So it's just sort of the ethos of it.
Yeah.
So we're not crazy to think that Bitcoin fixes this. Is Bitcoin going to make us as energy efficient as humanly possible if we put in the effort?
Yes.
I mean, the use of energy is what allows humanity to thrive. And if you want humanity to thrive, it means you need more energy. People use heat for lots of different things, and that's the primary waste product of Bitcoin. So, again, that fundamental principle, okay, what's the waste product? How can that be a primary input for another task? And Bitcoin can thrive there. So Bitcoin fixes this.
Gets me all bullish. Why don't people realize this yet?
That's a good question, because it's out of the norm. It's out of the box. I mean, I've kept my hot tub warm all winter using waste heat from a miner.
Just one?
Subfloor heating gets preheated by a Bitcoin miner. Like, do I pay for the electricity? Yeah. Well, I also am experiencing, 0-degree weather. So I need heat too.
Yeah.
So, off-grid Bitcoin flare gas mining is just another step removed from the electron. It's just one step above that, so to speak. So it's just finding where the forms of energy that's useful and how to harness that. It's a no-brainer.
Yeah, it is a no-brainer. We have some asymmetric information here, which brings us to the topic why I really brought you guys on. Right now, we've been focusing on like the actual design of a mining operation, but you guys go even deeper than that, and you've been doing a lot of research on underclocking and overclocking, particular ASICs. I posted a big thread from the Cathedra Twitter account a few weeks ago that got hot, and a lot of people seem to love it. But I think to highlight the breadth of knowledge that you guys have in this space, like we just described, designing and architecting these environments in which the miners live, but then once the miners are plugged in and running and you have a stable environment, there's more that you can do at the machine level that you guys have been tinkering with. So obviously you've been tinkering for years now. What have you guys found?
You know, the bear market gives you an incentive to change your perspective. I do have to say that. You know, everybody looks at a big, when you say aftermarket firmware, everyone says automatically thinks overclock. Oh, I'm just going to push farther and farther and farther. It's not necessarily that. So, and ASIC helped me kind of see this. When you start conventionally, when you say, hey, I'm making a container, you are physically restricting the number of, and I call them parking spots, but rack space, and saying, I have X many rack spaces for X many machines, and I need to then size my electrical to that and say, okay, this is how much power this container is going to use. But what if it was a flexible thing? So it was saying, I am restricted. What you're saying is, I am restricted by my rack space. Well, right now, the dollar per terahash of machines is cheaper. I rather buy a second machine at a more efficient and run it more efficiently, because that's going to increase my operating profit. Period. So the way we were looking at and sizing things physically was, it's a static number. But what this aftermarket firmware has been able to do is that it's given us a knob, a kind of a fourth dimension knob to say, well, what if it isn't? What if you had more rack space? If you already have it, then why not utilize it? Especially if you're going to get more efficiency out of it. If you've already bought machines and just don't have enough power to plug it in, but you have rack space, why not utilize it? So it's in the cockroach mentality, how can I maximize all the assets that I have? Whether that's power capacity, whether that's rack space, whether that's restricted by power cost, whatever it is, you just kind of look at all those variables and say, is it really something that's static? And it shouldn't be. That's a long-winded way of saying it, but yes.
Yeah, I mean, I think I often think in terms of love your neighbor as yourself, and I find that same kind of logic works in systems. So if you just treat somebody as a vendor, or just say, okay, this is just the service you're going to give me, this is how it is, then that's the end of it, and you're just using that service as is. But if you sort of get into their perspective, you can unlock additional potential, and it allows for creativity and hard work to flourish in a way that it wouldn't otherwise. So just to kind of give you an example, so some of the generators that we would use, they normally provide 480 volt power. The Bitcoin miners, I won't get, I'll spare you the details, but in most of these builds, you need 415 volt power delivered to the build. You can either buy a big transformer, which has additional, capital expenditure to transform that, or if you know a thing or two about how the generator works, you can get around that. And so what you can do is you could reduce the stimulating voltage on the generator, and then it will output 415 volts with a certain D rate associated with the generator. So by paying attention to how that system works, that's not necessarily a system you'd think about, you can save a bunch of money. And that same kind of concept trickles up and down the chain here. So when you think about, okay, a miner is plugging into a given set of infrastructure, okay, well, how does that infrastructure actually work? How can we, fully integrate in a way that takes into account all the little nuances? And it's just this underclocking journey that Rete and I went on was born out of a problem that we had. So we had a bunch of pre-ordered S19J Pros that were delivered, and we're trying to get these things plugged in just as soon as possible. Well, we have this legacy site out of Washington State. And I mean, this thing is from back in 2013. It's a really old site. It was originally designed for S19s way back in the day. S9s. Oh yeah, sorry, thank you. And so you have tons of rack space, but the PDUs are relatively small for what you would today consider a standard mine. So basically, we were when we got these S19s, we're putting them on the rack. The stock power draw on an S19 is about 3,000 watts, and these PDUs were rated up to 5,760 watts. That two of them on a PDU. Yeah. Right. And so we start with just plugging one per PDU. It just seems like ridiculous, right? Because here's this PDU design. It's got 8 plugs on it, designed for for a bunch of S9s, and we can only fit one S19. It's like, this is ridiculous. And so then we sort of got clever and realized, okay, as long as all the phases match up, we can put 1.5 miners, per PDU. And so you'd split, because the S19s have 2 plugs, so you could split one over 2 PDUs if it was on the same phase. Yeah. And so then we got, 50% improvement, but we still had a bunch of miners that we're trying to get a home for. And it's like, okay, we have to fix this. And I was like, okay, what if we could underclock the miners a little bit, and then we could fit 2 miners a PDU? That would be much more efficient. And so we started thinking in that way, and we were doing some testing, and it's like, hey, we can do this. Yeah. And then I'm between the two of us, between Rete and I, I'm probably more the cowboy. And so I just got to thinking, well, hey, wait a minute. What if we underclock them even more? What if we just stuffed 3 or even 4 on a PDU, and everyone on the team just like, Isaac, you're freaking nuts. Like, what are you talking about? Yeah. We could barely get 1.5, and you want to put 4 miners on a PDU? I'm like, yeah, I think we can try this. And this comes from, again, having an intuitive understanding of the way this stuff works is really, really helpful. And a lot of that comes from pain, as Rete pointed out. So Brains had put out this really great piece of research on how temperature can affect the watt draw on an S19 model. And I was like, okay. And at a fundamental level, that makes sense. So just to give you kind of a first principle approach, how I think about this, I think of chips as these little cities, and electrons are like the little cars driving around inside the city. You get to change volts and frequency. So frequency is how fast the stoplights turn red and green. Those are the logic gates. And the voltage is the kind of engine you're putting on the electron. I know there's lots of other models. You can think about it as, water pressure and how big your hose is. Lots of ways of thinking about it, but this is the model that I sort of use. And it's like, okay, these chips are smaller, so now you have to start thinking about the quantum physics of this, because you're at a scale now where electrons can quantum tunnel through the logic gates. Like you're getting to a point where you need to think about what's happening, at the electron level. And it's like, okay, well, what is temperature to an electron? So think about driving down the road in your car and somebody's shaking the road like an earthquake, back and forth and back and forth. That's how an electron perceives heat, because temperature is
vibration.
It's vibration at an atomic scale. So an electron is just trying to go along its merry way down, the path on the circuit board, and it gets hot, and all of a sudden the road's shaking all over the place, and it's veering and hitting on the gas and coming off the gas. It's very wasteful. But if you can stabilize the road, make it nice and cool on the chip level, the electron can get to where it needs to go without using as much energy. And so, okay, Brains puts out this piece of research and says, hey, these chips are very susceptible to temperature. It makes sense. They're a smaller chip. They're more susceptible to vibrations. It's the difference between, okay, I'm going to be on an 8-lane highway that's shaking back and forth versus, I'm going down, a little cobblestone street in Rome, right? I'm trying to squeeze through because it's a tinier chip. You're much more susceptible to vibration. So how can we reduce heat? Well, you could, immersion cool these things. You can, feed it liquid nitrogen. There's all sorts of things you could do to keep it cold. But one way that people don't often think of is, if I run less power through this chip, there's going to be less heat, right? I'm reducing the heat density because I'm reducing the power density. So if you use less power, it's more stable from the electron's perspective, which means it should get more efficient. And so, Brains was doing this with stock clocks and overclocking. It's like, well, what if that concept holds downwards as well? So what if we could make it more efficient?
Yeah.
So that's just, a first principles, what we're, and we tried, and it seemed to work. And we ended up getting 4 miners of PDU at this legacy site because we were able to reduce the power going through each individual machine, makes a more stable environment on a per chip level, and you get more efficiency. So if you think about your site as okay, I have X power coming to this site, and then Y output, your hash rate, you just need to stuff it with more machines, but then you're getting more incremental hash rate for the given power draw, which means your margins improve. So it's better to think about it in terms of, hey, how can I get more money out of a respective site than how can I get the most hash rate? During a bull run, if Bitcoin goes to infinity, you can afford to mine at any price. So you just want every hash you can get. In a bear market, you want the most efficient builds. So you want to overclock in a bull run, overclock in a bear market. So now that opens up this whole possibility. What if you can have these flexible clocks that respond to network difficulty and hash price, maybe your ambient temperature, so you can start to get pretty sophisticated in thinking about how all these things are affecting your net profitability. But anyway, maybe I've said too much, but go ahead. Someone else talk.
I don't think you said too much. This is fascinating. Rete, do you have anything to add to that?
It comes out of necessity, right? For me, the 4 miners per PDU at a legacy site, I was like, oh, come on, man. Like, seriously? Like, how do we do that? I'm a visual person, and that's where all these maps came out and said, okay, well, let's look at what this machine does systematically, right? And is there a sweet spot? Is there some way to quantify this? It's easy to kind of pick and choose things, but if you don't have like a good roadmap to it, the data doesn't really mean anything. Okay, glad you got to underclock. It's more efficient. Cool. Is it the best way to operate? And the answer is not really. So if you can find this channel, so we found that there was a point, if you underclock too far, it wasn't as efficient. There was a kind of a de minimis point of saying, here's kind of this area that works better. And that's kind of the range that we want to operate in. I think that's true on the high side as well. I'm still going through step by step on the overclocking side. It's a little bit different, but not that much. Same concept is that there is kind of this channel where it works the best. And that's, using the kind of cars and lights analogy, is that you don't want to have too fast of a car because then the lights are going to be out of sync. You kind of want to have them in sync, and that's going to be the best place, regardless of whatever volt frequency combination you have in the most efficient band.
Yeah, so just kind of leapfrogging off
one
of
more
that.
thing. To Isaac's point, that just mapping things out is only the first layer. You can continue that in saying, what machine mix do you have? And you just keep on layering machine over machine over machine. And then you start to get the shifting map and saying, this is how I want to do it. And if you have two different power mixes, for example, site 1 and site 2, you can start optimizing how you want to place your machines and at what watt per terahash. So it gets a lot more, that's essentially what we're working on, is how can I use this fourth dimension of the machine's capability, and how can I make a good decision off of it? That's essentially where it's going to go.
Yeah. So we're at even though ASICs have come very far and are extremely advanced now, producing a lot of hashes, getting more and more efficient, on the management side, it seems like we're still in the Stone Age or the Bronze Age, where we're figuring out, it seems like what you guys are describing paints the potential for a crazy integrated system that in the future there will be processes and software that basically, like Isaac, like you mentioned, will look at difficulty and hash price at any given point in time and then manipulate the operation to be as efficient as possible from a profitability perspective.
Yeah.
Yeah, and that sounds wonderful, except then you need to figure out how to calculate uptime, because it starts to get because you've got your our target hash rate was this at this time and something else another time. It's like, okay, and most people, they're saying, okay, this was our uptime. I expect the machine to produce this much hash rate. I expect my power bill to be exactly this every month. And it's like, okay, now we're going to just mess up the account.
Well, at that point, you just change the KPIs, right? Like maybe optimal hash rate production per machine isn't the right KPI. Maybe it's profitability per machine. And if you sort of target profitability over optimal, or not optimal, profitability would be optimal hash rate, but as much hash rate as possible. Maybe that's something the industry should move toward.
Well, and you have to kind of consider macro conditions in too. It's depends on when you bought your machines, right? Did you buy at the top of the bull market at $100 a T? Or did you, do you have cash right now, and are you buying machines at $15, $20 a T?
Right. Well, and here's one of the implications of this, from a, minor allocation standpoint, what do you want to buy? I mean, today, like an XP goes for about $6,000. An S19J Pro is going for about $1,600, $1,700, right? So what if you can underclock an S19J Pro and get not quite as good, but get comparable efficiency to an XP, very similar. Do you want to spend $6,000 to get that level of efficiency? Or do you want to spend, $4,000 to get something of comparable efficiency and comparable hash rate? And now the downside is you need 2 rack spaces instead of 1 rack space. But presumably you could, get that rack space for less than what the difference is, which would be $2,000. So in terms of, hey, what machine are we going to buy? If you use techniques like this, it can unlock, capital allocation in a way that you may not have looked at. So, yeah, it's just about saying, intuitively, what is each system capable of, and how can they integrate well? Because someone who isn't using this kind of firmware take, and they just want the best efficiency, they're going to buy the XPs. But if you can, kind of use this firmware hack, then you can get that for less, right? And that's what it's all about, doing more with less.
There's going to be whole teams dedicated to figuring out like the correct capital allocation, rack space. Yeah, because there's so many variables.
Yeah,
rack space, electricity cost, terahash per machine. It's insane to think how complex. Is it complex? Yeah, it's complex. It's a complex system. Like how complex this is going to get, and how much brain power is going to be dedicated. Like you're going to have a whole trading desk trying to figure this stuff out.
Or Chat GPT. We'll see.
Oh, just ask Chat GPT. Yeah. Make sure you ask it in the right way.
I mean, wouldn't be surprised within a few years, one of these AIs, you're able to be like, hey, here's what I'm trying to fine tune for.
Yep. Mine GPT trademark.
But that's kind of the thing of where you this is the difficult part, right? Is that, do I buy more rack space? Do I buy more power capacity? Do I buy more machines? It's all a process, and it all has to kind of work in this flywheel sequence, right? Like you can't have more of one thing and then not have the other. Otherwise, you get kind of behind the 8 ball, and you want to make sure that you might go make deals that you don't like or something else. But if you kind of use this as kind of a tempering mechanism, saying, what is rack space really worth? Right now, containers, rack space, it's cheap because nobody's buying them. But the long-term value of them, I think it's severely undervalued right now. Rack space is severely undervalued right now.
Yeah. And what you're getting at is that these decisions are dynamic. They're changing with every block that's produced, and with every tick of the price moving up or down. So you have to have the ability to make the correct decision in a dynamic way on the go, depending on the market conditions.
Yep. And I think eating smaller steps. So instead of saying, I got to go build a 100 megawatt facility, it might be, hey, I'm going to make these decisions in smaller increments and have the ability to do so. And then kind of roll it in smaller chunks, which actually if you take a 10,000 foot view, de-risks a lot of those decisions, I think.
Yeah, that's one thing I've become partial towards over the last 2 years, is I think these mega mines are not going to be the wisest way to build out a mining operation moving forward. I think taking off smaller 5, 10, 20 megawatt chunks at a time makes much more sense.
Yeah, I mean, no problem with trying to go get 100 megawatts worth of power capacity, but the infrastructure and what goes into it, and when you buy machines, how you buy machines, and then you start filling into it, I think that process should be, I don't want to say compressed, but kind of concurrent.
Yeah,
it's really hard to say I'm going to buy 20,000, 30,000 S19s, a year and a half ago.
Yeah, you have to develop like a just-in-time process, right? Where as soon as the electricity's up, the rack space is up, and you're able to plug in, you should have that project management set up where, all right, as soon as we electrify, we are plugging miners in.
Yeah.
I think that the underclocking play is going to have I think it'll have outsized effects on profitability relative to a more distributed model. And what I mean by that is if you look at a mine that's on grid, one of these mega mines, right? They sort of have no penalty necessarily. I mean, every site's different, right? Sometimes you have a minimum offtake, what have you. But if you say, all right, well, I'm allowed to reduce how much power I pull from the grid without penalty, then in a bear market, when hash price drops below whatever point the stock firmware machine would go unprofitable, well, what if, hey, I can underclock now, increase the efficiency on a per machine basis. I'm reducing my overall power use, but I'm still profitable as a site. That doesn't quite work the same if you're off grid, because in that situation, if you're renting a generator or you've purchased a generator, you already have you already have that as a payment, right? Like, and that doesn't change. It's sort of like buying a generator. You can think of it as having committed to a minimum offtake agreement. I'm going to buy exactly this much power, and it's pay or take, if you will, right? So you're committed to using whatever the capacity of the generator is. So in that context, sure, you can make the machines more efficient, but if you're using less power, you're just underutilizing something you've already paid for. So it may not make sense unless you can somehow pull generators off, or maybe you could bring another container on site and use more of the generator, right? So it's more sophisticated. You can still use it. It's just it requires more playing with the physical infrastructure. An on-grid site, they can push an underclock and they just stop using as much power from the grid, and their margins are improved on a per watt basis. So a little bit of nuance there.
Yeah. Now we're dovetailing into like Bitcoin mining, changing the game of these PPAs, how they're structured.
Yep.
Like what is allowed, like going and educating utility side of the equation, like, hey, we're going to do this weird thing that probably no other customer you have wants to do, but trust us, it's worth it in the long run for you.
Yeah, I mean, in terms of integrating with utilities, I mean, that's a whole other can of worms with the firmware side of things. I mean, so right now, the way it works is if you want to, participate in demand response, you're just turning off machines. I mean, that's how it works today. You suspend mining, or if you have a smart PDU, you just turn the miner off altogether. But you're basically keeping your same rate of efficiency when you participate. So if you're, let's say, okay, you're, whoever manages the grid, whether that's an RTO or a municipality, whatever, says, hey, we need you to turn off half of your power use. Is half of the miners get shut off and the other miners are still running at the same efficiency. But what if instead you said, okay, I'm going to reduce my power use by half on a per machine basis. So during that curtailment, you just make all of your machines more efficient. So you're increasing your margins in that curtailment. That's more money.
You're
in your
juicing
pocket
your margins, right? Because you're still mining with every miner more profitably, and then you're getting paid for turning down.
Yep.
Right. So that I think that's sort of where we're headed is having dynamic tunability on a per miner basis. I think that's going to create huge margin boosts for a lot of these on-grid sites.
Yeah. That's going to be massive. Talk about
which is not
business.
Even demand response, right? Like, well, it is a demand response, but it's not like a binary decision at that point.
Right. It's a dynamic response versus a binary response. You're scaling your hash rate up or down, and so you're responding to the request to curtail, but you're doing it on a per machine basis. And as you do that on a per machine basis, you're increasing your efficiency. So you get more hash rate out of the power you are allowed to consume at that time. So yeah, that's where we're headed, I think.
This is like some sci-fi shit here.
Yeah, and half the time, Rete and I have conversations like this, like, "Hey, can we do this kind of thing?" I mean, one of the things that we've been talking about recently is, "Hey, what if we could be designated as like a virtual power plant? So we're a buyer on the per kilowatt hour market, and we're a seller on the capacity market, and so you just if the grid is asking for more power, you just turn off. You don't even have a power plant on site. It's just direct tied to the grid and." Anyway, we have these crazy conversations, and 9 out of every 10 just die on the drawing board because it's just too nuts. But every now and then something comes through.
I'm just a simple miner. Let me mine.
I think that's what we're getting at. Like,
yeah,
mining is much more complex, and especially if you want to be profitable and in it for the long run, like you have to have these types of discussions and this train of thought.
And I think, I'm really thankful for Rete. I think we make this really interesting team where I'm just sort of this cowboy, like, hey, let's just throw stuff at the wall and see if it sticks. And he tolerates me enough to hear me out, and then will calmly explain why I'm just so wrong. But every now and then he goes, well, wait a minute, maybe there's something there. And then, So like, hey, can we look here? And then he just dives down on the, like an electron microscope and says, hey, did you think about this? I'm like, oh, no, that nukes the whole idea. Never mind. And then we just continue on. But it's this sort of, this great interplay of I'm just pushing the envelope and he's like, whoa. And sometimes we fight like an old married couple about stuff, but we always, it's great.
That's an understatement, but yes. Ideas have to be able to be executed. So when physics are defied, then I will put my foot down. But, when you get into this, I think there's so much potential in this firmware space and unlocking the potential of the machines. I mean, that's just one step. Right? Like, but you still have to make the environment conducive. That's where Bitcoin comes into a physical, in contact with the physical world. So if you don't make the mining machines happy, they ain't going to work for you. So, we can do all this fun stuff, but like as part of what we wrote, like I could have the same volt frequency, on the graph, so to speak. But if that temperature is way up here, doesn't matter, right? And that's controlling your environment. That's making sure that everything kind of works in concert in the way that you've hopefully designed the system.
Yeah, that gets to another point, like with all these efficiency gains and the games that you play with voltage and stuff like that, it's going to be hard to tell because enough time has not passed yet. But do you guys have inclinations on what this will do for the life cycle of these ASICs?
You underclock them. It's I don't have the back data, but my gut instinct is it will expand the life of that machine as long as you don't have dust going in and mucking it up. Like,
right. Yeah, I mean, it's a very simple concept. Take care of your things and they last a long time. It's very simple. Take care of it and then figure out what it needs to run well. I mean, just as a first principle concept, I look at the the S9. When Brains came out with this great firmware, it was an underclock, right? But that extended the whole life cycle of an S9. Mm-hmm. And I think what we'll see is that trend will continue with lots of other miners, where underclocking pushes it into a more efficient regime, and then you can afford to run it longer. So I think it'll change. Yeah, it'll change a lot.
Yeah, it's crazy to think that the average life cycle of an ASIC before the S9 was like 18 months. Now people are still running S9s today, 8 years almost later.
Yeah. I mean, but now they've modded it to a double shoebox, like one power supply for two, like.
Yeah, I mean, yeah, looking at what Bitmain did with their S19, I really respect sort of their take, because you look at the thing, it's like, why does this have two plugs? And then if you think about it, it's like, well, they've got their own mines as well, and all of that infrastructure, and including their customers too, right? It's all designed for S9s. And you say, okay, I'm going to double the power use on a per machine basis. Am I going to put a bigger plug? Am I going to put that C19 plug and make everybody gut their mine and rebuild all of their electrical infrastructure? Or am I going to put two plugs, and anytime you pull out one S9, or sorry, you pull out two S9s, you can put in one S19. It fills the same space on the rack. It works electrically, right? And so I think manufacturers are starting to think more and more about the infrastructure side of this. Where are they going to plug? Where are these things going to go? And again, that gets back to the concept of loving your neighbor as yourself, right? It's like, where is this going, and how can it be used well? I mean, Bitmain coming out with these new three-phase power supply. I can't talk.
Yeah.
PDUs. I think that's going to be game-changing for a lot of folks, right? Because when you build out this mine, you don't necessarily have to do the same amount of work, pulling all the phases apart. You can just deliver the three-phase right to the PDU, and then it gets, the splitting up gets taken care of at that level. Stuff like that, where it's thinking about how it all works together, it's going to become more and more important.
And to that point, just due to like the limits that the ASIC industry is beginning to brush up against, do you think on that side, the PSU, PDU side, we've reached like a point of commodification where you don't have drastic changes from one model to the next?
It's everything is size, really. I mean, you can make these really big things, more amps, more, it's going to be really interesting in how the power side is going to occur for these machines, whether or not they're going to be like, hey, we need bigger and bigger PSUs on these things. If that's the case, we're kind of at the standardized plug limits already. Can't do it. So one thing that you can do is go to three-phase power. You will need to modify your farm a little bit for that, but I mean, I can still use 14 gauge wire and push 8,000 watts through it in three-phase. So
sort of reaching that point. Is that what you're saying?
Yeah.
Yeah, I mean, like, what are you going to do? Put a dryer plug on a miner? I mean, where would you put it? There's just we're reaching sort of the limits of what electrical engineers had thought up for quite a long time. I mean, Bitcoin mining is pushing with these these specialty industries, right? Like there is not a computer plug. I mean, maybe the L7, but like in general, the C19 is your limit. It's 20 amps, right? I mean, if you want to go bigger than that, if you want to go higher voltage than that, then you start reaching problems with, arcing, which is why everything is rated 250 volts or less, right? That's an electrical standard. Yeah. So when you start to say, hey, I want to increase the voltage for efficiency, or hey, I want to put more amps through, you're reaching the limits of what's permissible under electric code. Like, there just isn't a plug that can handle these things. So you have one of two options. Either you put, as these chips get more and more power hungry, or, they're putting more chips on a board as they get more efficient. If you want to use more power on a per machine basis, you've got to go three-phase. You've got to start doing direct wiring right into the unit. There is no plug, stuff like that.
Yeah.
The other way to handle it is you just put less chips per machine, and you keep the power the form factor the same, right? Because of the limitations in electrical code and like what's physically possible. So I think you'll start to see, I think either you'll start to see more three-phase stuff come to market, or you'll see people using the same sort of power form factor and they just put less chips.
Yeah.
God. You two are so fucking smart. Thank you for the education you've given me over the years that we've worked together. I think you guys, the two of you, Austin, Tom, have really helped level up my knowledge of this space. It's crazy.
But we've, and that kind of boils down to the fundamental thing, like the team matters, right? If you have a lot of people or good people to kind of collaborate with and educate and kind of lean on, you're golden.
Yeah, well, it's just, it's staying humble and working hard. And, part of being humble is listening. Just recognize that, hey, you never know where the best idea is going to come from, and just being open to it. No, I think that's something you've done really well, Marty. I think that's why you're such a captivating, podcast host. It's like you just you know where to you know where to let people just run when they want to go all crazy. So I don't know.
Well, I don't think it's crazy at all. Thank you for the hosting compliment, but I'm being earnest here. Like, talking to you guys is multi-hour long phone conversations, trying to understand what the hell you two are working on. Significantly upped my game personally.
I mean, I assure you, like, we feel that way most of the time. So it's not it's like, there's so much of this stuff that is a master electrician, they'll spend their whole life devoted toward understanding all these crazy nuances, harmonics and, phase shifts and, there's all this stuff, right? It's a very, sort of enshrined discipline, and networking and data management, network security, HVAC systems, structural engineering and welding. Like, there's all of these crazy disciplines that Bitcoin and Bitcoin mining pulls on, right down to economics and, political theory. I mean, there's all of this stuff that just gets sucked into it. And so you're never bored, but often overwhelmed and feel like the stupidest person in the room. But it's just a matter of, I often describe Bitcoin mining as just, just enduring pain. You're just like, hey, I'm going to just, that's why I say you got to stay humble. If you got,
it's very masochistic.
Well, it's not, it's always listening. I mean, you say, stay humble, stack sats. The stay humble is listening to your environment, listening to the listening to the market, listening to what is needed to make this ecosystem thrive. And so, like I said, I'm not an expert. I just know what has caused me pain, right? And that just keeps on stacking and stacking and stacking. So I can say, hey, I know that you want to go this direction, but really what you want to do is go this way.
Yeah.
Don't make the same mistakes that we did. Or, hey, by the way, there's a pitfall right in here. It seems like a good idea, but it's not. And that's just experience. So the more people we can get in here to get that kind of experience into this, like, I'm an open book. I'm happy to bring more people in. That's what's going to accelerate adoption and just make this ecosystem work.
Would it be, I mean, would it go too far to say that, like, Bitcoin mining as an industry, considering all the different variables and core competencies it pulls on, could incite like an engineering renaissance?
Wow, I could.
Well, because what Bitcoin mining is doing currently is it's disrupting the idea of a specialist. Because if you just have an electrical engineer specialist and an HVAC specialist and a data networking specialist, I mean, sure, you can go get all those specialists and get them in a room together, and then like it's going to take a while, right, to get everybody on the same page and what you want to go build together, because there's a lot involved in these sites. Or you can have somebody that has basic competency in each of those respective areas, and they're more like a conductor than a musician, right? They allow each of the specialists to do what they're really good at, and they have an understanding of the other disciplines, right? And so I think Bitcoin mining is bringing back the Renaissance man. You have to know a little bit about a bunch of stuff if it's going to work well. And it's great to have specialists in your court, but a specialist, on their own is not going to be able to make a good mine.
I think the specialist is absolutely there, but it's easy, especially to say, if you're a civil engineer, you're going to talk to some other civil engineers. You're not really going to talk to the other guys. And if you do, it's through a consultant or it's through some manager, project manager. I think having a diverse skill set team is very important, especially if you have a lot of different experts in from those fields. But you need to make them to work together towards a common goal. And if everybody, if you believe in Bitcoin and everybody believes like that's the future, then you already have a common goal in mind. It's just about working together at that point. So if you can kind of unite around the Progress platform, absolutely. I think you can have a lot of different disciplines working together, and as they do already, but more integrated in that way.
Yeah, fuck, I'm bullish. It's
always have been. We've never lost that bullishness.
No, but it's, again, like sitting down and putting this all together. Like Bitcoin mining could bring back the Renaissance man in the engineering sector. Like, you have to, like you said, I really like the conductor analogy. Like, you have to be able to understand how the different parts interact with each other.
Yeah.
Yeah, I mean, if you're always playing the same song, every week, week in and week out, eventually you don't need the conductor, right? Because the musician just sits there and they're doing exactly the same thing off the same piece of sheet music. It's like, it doesn't change. So you go, okay, well, we don't need the conductor. But once you start changing the song and like you uproot the status quo on the kinds of engineering you're doing, because it's very dynamic. There's lots of systems at play here. And so when once you start doing that, you need the conductor back to keep everybody in sync. Otherwise, it's just a mess.
I think this.
That's funny.
I think this rip is going to be very popular amongst the mining industry because, again, I think a lot of people have a rough idea about all these problems you guys are describing. And as you said, you're not experts, but I think the experience that you two have goes far beyond a lot of the individuals in the space. I think that, I mean, we saw that too when you guys launched the thread on the research that you did on the underclocking. The response to that was like, holy crap, I can't believe somebody did this. Thank you for sharing it. I guess that's another thing to touch on, like, why share this? Isn't this alpha? Shouldn't you hold this close to the chest? That was some of the feedback from the thread.
We thought about it in that way, but I think it's hard if you're trying to promote this Promethean existence, like you want to share the platform to do it. I'm not telling you how I did, how I'm writing my own algorithms or all that. You need to go put in the work. Sometimes it's just about showing, hey, here's the possibility, right? I'm not perfect. I might have blind spots, but I would respect the guy who uses that as the platform to say, hey, I looked at it in a different way. How about this? And if he shares that too, then it perpetuates that cycle of sharing, mutual progress.
I mean, that's how a renaissance happens. You need to get people talking.
Yeah.
And if everyone's, covering their butt with proprietary jargon and patents, I mean, the industry won't move forward, right? I mean, like, I remember, when I first got into mining, I mean, there were no YouTube videos, there were no tutorials on how to build these things. It was just like, okay, I got to just Google a bunch of random stuff that sort of has proximity to what I'm trying to do. And I mean, I remember back when I was building GPU rigs, like there was just no information on this stuff. It was just a lot, like just sheer pain, banging your head against a wall day in, day out for months before I figured it out. And there were a lot of people in the space who had built before, and they were showing people how to build these things. I mean, go right back to Satoshi himself. He made it open source. He put it out into the public domain, said, here guys, this is what I'm trying to do. This is what I'm trying to build. How can you help me make it better? And that, that's really the spirit of a Bitcoiner, is we're going to build a better world together. And to do that, you can't always be worried about, oh, someone might be trying to stab me in the back. But part of this is, hey, we're all in this together, as Bitcoiners, and we're going to optimize and build better together. So, and it's just about staying at the tip of the spear. It's about saying, look, we're going to be thinking about these hard things, thinking about these problems, and try and be among the first to adopt these novel techniques and technologies. Yeah. And if you just are constantly staying there, everybody improves while you do well. And that's a better world. That's how you build a better tomorrow.
Hell yeah. We're going to win.
Always.
What
together we win.
This is true.
Yes.
What should we send the freaks off with? Any final thoughts? Anything you guys want to touch on before we wrap up here?
Just test. Just work on stuff. If something interests you, it's possible. You might not know how, but that's part of the process. So there are a lot of resources, a lot of parallels that you can draw. I mean, I got my hot tub heating loop from a wood boiler stove idea, right? Like, okay, that's the way I should design it and go from there. So there are a lot of things that you can borrow from. Just share. I like the idea of sharing on some of those ideas, and just go test it. I want other people to have this graph and make their own graphs, so that it's like, oh, well, they did it a different way. That knowledge sharing, I think, is what I want to see out of that.
Yeah, I would say all hard work yields a profit, and sometimes it takes a while, but there's something that comes from excellence in any discipline. If you do something well, you will inevitably discover areas that are urgently involved, and it's just about staying curious and saying, hey, what are the things that interest you? And saying, even if it's 15 minutes a day, I'm going to just walk in this direction because I'm fascinated. And it's just, I remember my first GPU rig. I tried and tried for a couple months. I couldn't quite get it. I was teaching myself how to build a computer here. And I remember I stopped for a couple of weeks. And I just remember thinking, no, I decided to do this. I decided I was going to figure it out. And I went back to it, and I finally got the thing going. And like, there's nothing so sweet as, wow, like this was so hard, and I got it. It's like, I think about who's the first guy that made fire, and like how crazy that must have been. Like, I did it. I figured out how to do this. Right? Think about how long that must have taken. Literally, there's no YouTube tutorials. There's no one somebody had to go figure that out for the very first time. And like that's hard. And each one of us has this sort of personal journey. I've got 2 young boys, and there's just this like crazy light in their eyes when they figure out how to do something for the first time. Like, oh, I figured out how to turn the light switch on my own. Oh, I figured out how to unlock the front door. Oh, shoot, mommy, please, like that. But still, there's this beauty in that. And so it's just work hard and, stay curious, and don't, the future belongs to those who believe in their dreams. So just don't give up.
And Marty, thank you for what you do and giving people like us a voice, right? And being curious about what's going on, because you, above anybody else, understand that it takes so many different people from so many different disciplines to make this all go forward. Pretty much.
Yeah. I mean, that was beautifully put by both of you. And the thanks goes both ways. It's been a net benefit, massive net benefit to my life working with you guys and learning about all this stuff. And I'm extremely happy. I can't believe it took this long to get you guys on the show.
I know.
I'm extremely happy that it has finally happened, because I think there is going to be a lot of aha moments for people in the mining industry listening to this. And like you said, again, Bitcoiners giving back, really trying to live close to the ethos that Satoshi set forth when he launched the protocol is what's going to create this cascading effect. I do think, particularly in the mining industry, there is a bit of keep things close to the chest. That's your alpha. But I think considering the enormity of the problems that we're trying to solve, I think this will have a positive feedback loop, sharing this information and really putting this out there. So thank you, gentlemen, for doing it.
Pleasure.
Yep. We're in it for the plebs.
Hell yeah. Well, it's been fascinating. We'll do this again, I'm sure.
Sweet.
Awesome.
It's not going to take 5 years this time.
I hope not.
Oh my gosh, has it been that long? Oh my word.
I'm going to be all gray by
Wow.
then, if that ever happens.
You'll be all gray, and I'll be joining you in the bald crew. So
Hey, bald is beautiful.
it is.
Don't
It
let
is.
anybody tell you otherwise.
All right, gentlemen. Thank you.
Thank you, gents. Cheers.
Seriously, thank you. You guys are fucking crushing it.
Hey, love you, Marty.
Love you guys too. Peace and love, freaks.
It was fun.
Isaac, you want to get it? Oh, I got this
Go.
here now. Peace and love, freaks. Tiki.